Hello, this is Mr. Jackson, and today I want to talk about systems, but this time I want to start calculating some forces rather than just drawing them out. So we're going to draw and then find some answers for some missing information. So let's start out with a simple system. Let's take and have a ceiling, and in the ceiling we have attached to it two pictures that are hanging by two strings, and one is bigger than the other. So you have this artwork hanging up, and let's say that this is a 5 kilogram picture and this one is a 11 kilogram picture. Okay, let's try to figure out what are the forces, and we'll call this string 1 and this is string number 2, or cable 1 and cable 2. And we're going to ask you, what are the values of these numbers? But to do that, we're going to need to find out more information. We need to know all the forces going on. So let's think about them. In this bottom box, if I ignore the top, I notice I have a force of weight. Okay? And let's just use the value of gravity being 10 rather than 9.8 to make this faster. 10 times 11 is 110 newtons. Okay? And then there's a force up known as tension. So force of tension. Okay? And that's what I see on this box. Now on this box, I can see that I have a force of tension down. I have a pull of the ceiling, so another force of tension upward. So there's two tension forces, but I know that there's weight in this, so there's got to be also a force of weight downward. Well, 10 times 5 is 50 newtons using gravity as 9.8. So those are all the forces. The upward one has 3 forces. 1, 2, 3. Then the bottom one has 2 forces. Okay? And now, how would I figure out the tension in these cables or calculate them? Well, here's how we have to think it through. If I want to find the tension in the cable, then I only look at one object at a time. So I'm going to look at just this one to determine the tension in this cable below. Because right now, this top one's acting like a ceiling. Okay? So if I find the tension here, I've also found the tension there. So I don't need to do it twice, and I don't need to add these numbers together. Okay? So here it is. We know the system is at rest. It's hanging on the wall. So if the acceleration is 0, F net is 0. That means if it's a vertical system, the up equals the down. So here, the up must equal the down. So the force of tension here has to be the same as the tension there. So it's 110 newtons. So this tension is 110 newtons. Okay? Now, how would I find the tension up here? Well, it's up minus down. Okay? So this one right here would be equal to all the downward forces. We just found out this one's 110. But there's also weight acting down. So I'm going to have to, if I cover this up like this, I'm going to have to understand that then these two downward forces have to be balanced upward. So then this one right here would be 110 plus 50 newtons. So it would be 160 newtons would be my tension in this first one up here. Okay? So that's how you find it. You have to maybe take a piece of paper after you draw your system and cover it to think about up minus down. Okay? So vertical problems, when it's at rest, up equals down. Here I do it again. Up equals down 110. Okay? That might help you a little bit. Let's do a horizontal problem. Okay? Let's do one that maybe a car is driving along. Okay? So here we have a situation, and we have a car pulling a trailer. So I'm going to make this a little bit longer. I know it's not that far behind, But I just want to make it simple so we can see things. I got room to draw stuff. So here we have a car pulling on a trailer, okay? And I ask you some questions like, okay, let's say that this trailer has, 150 kilogram weight. Let's say the truck is 450 kilograms, okay? And we just give you, it's going at constant speed, so my speed is constant, okay? So there's no acceleration. Acceleration is 0, so F net is 0, okay? And I want to start evaluating it and start figuring out the tensions and that kind of stuff, but I got to give you some other information. We know when they go down the road, there's drag, okay? So let's say that the truck is getting a little bit more drag than the trailer. So let's say the truck is getting, 150 newtons of drag, and the trailer here is about 80. So force of drag, 80 newtons. And this is a force of drag. Okay, it's a D there. Okay, so I've got this information. Now, let me ask you some questions. How many forces are total on this car? Well, is it on the ground? Yes. So there has to be force of normal and force of weight. Okay, that was not present in this one. There was no normal forces because they're not touching a object or ground, and they're not being supported. Okay, there's no air drag because they're sitting still, but this one had drag. We're going to ignore friction. Okay, and so I know to be moving, it's not accelerating, but it is moving. So we are moving. So we know there must be a force applied. So this one has 1, 2, 3, 4, but I gotta be careful. It is attached to this trailer. So there is a force of tension in there. So I see 5 forces. Okay? This one, I know there's a cable attached, so there is a tension in there. And they're equal, the same numbers. There is also a weight, and there's a support force from the ground, and there's drag. And I don't see any more. We know it's not has an engine, so we have 1, 2, 3, 4 forces. So there is the forces that I would identify for that picture. Now, let me ask you some calculating questions. Okay, what or how much tension is in the cable? Well, I told you this is pretty simple. All we got to do is, if I want to find the tension in the cable, just look at half the system. So let's just look at half of the system, okay? So here we go. If I find the tension here, I found the same tension there. I don't add these together. So let's just find it. Remember, in the vertical, it's up minus down, but in a horizontal problem, it's left minus right. So if I want to find this tension, I just need to find, since it's in the right direction, I got to find all the ones in the left. Well, all I wrote was 80. There's nothing else over here. If I had friction, I'd have to add these two numbers. But I don't have any friction. I said to negate it, not to worry about it. So that means that the force of tension, which means right, has to be equal to the left, which is 80 newtons, because we're going at constant speed. Okay? So that's how I could figure out the tension over here. But what about I ask you, can you figure out this number? Well, sure. It's really simple. We just cover up and look at half the system. Remember, if the tension over here is 80, the tension over here is also 80. And then at constant speed, right equals left. Okay? So that also has to be that, but I have drag. So I have 2 in the same direction. So I have to be careful here, since I have right minus left, but left has 2 numbers. I have drag and a tension from the trailer. I have to add them together. 150 plus 80 is 230. Oops, sorry about that. 230 newtons, and that 230 is going to be equal to the applied force right there to cancel it out, to stay at the same speed. So I did need both those numbers, and this trailer helped me find it. Okay? So the answer is 230 to maintain that speed. Well, let's make it a little bit more difficult. Let's say I have a situation where I have a helicopter. And let's say this helicopter is moving upwards. So here we go. We have our helicopter. Got my helicopter propellers, my back propellers hooked there, and we've got this cable acting down on this big box. And let's say that it is accelerating upward, okay, but we'll get to that in a minute. So let's figure out all the information. Let's say this is a 100 kilogram box. This is a 600 kilogram helicopter, okay? And let's figure out some information. Let's first of all, we can figure out the tension. We'll call this our cable, okay? We know that there's a force of weight down. 10, we're using a value of 10. 10 times 100 is 1,000 newtons. Okay? But there's also weight on the helicopter. Force of weight of the helicopter, okay, is 6,000 newtons. There's a tension from the box pulling on the helicopter, but then the helicopter's pulling up, force of tension upward, but they're the same value. Okay, and then let's say that our helicopter is moving up. Let's say it's at a rate of 2 meters per second squared. Okay, so there must be a force of thrust upward. Okay, and how can we figure out all these forces? And let's find the force of tension. So let's just say my first question is how many forces are in each object. So we look at this one. We know that the up has to equal the down. They're canceling each other, so we know that there are 2 forces. Okay? Here, we have a downward force pulling on the thing of weight of the helicopter. We also have the box pulling on it. They're trying to lift. And we have the force upward trying to accelerate and push this thing up in the air. So I see 3 forces here. And let's find some information. Let's find the force of tension, or Ft. How do I do that? I just look at one of the objects, and I'm going to make it really simple on myself. I'm going to find it here, and if I find the tension here, I've also found the tension there. I don't add them together, just they're one of another. So you just find one of the ideas. So if the weight down is 1,000, and then the weight up is going to be another 1,000, so this tension will be 1,000. Okay, but we're going to be careful here. I'm going to show you something. We have a problem with this answer, but I'll talk about it in a second. Okay, whenever you're at rest, so here's my at rest, whether it's vertical or not, the up equals the down. If you're accelerating, that means you have a force to hover, but then you must have a little bit more force to accelerate. So if you're looking upward, think of it this way. You have the force to balance the up and the down, so we'll call that force of hovering, plus you need a force of accelerating. Well, how much force do I need? Well, that came from the net force. And if I can find that force, I could add it to that one, and I'd find the full thrust upward, but that force would also impact the downward cable. So this is kind of complicated, so watch along. I want to find out, first of all, I need to remember, in a system, all the objects move. So I need to know all the masses. So here, this one's 600, and this is 100. So 600 plus 100 is 700 kilograms. Both are moving together. Okay? So that's easy to understand. But how much force do I need just to get acceleration? Well, I multiply these two numbers, F equals ma. So 700 times 2 is 1,400 newtons. So I need 1,400 newtons to get my acceleration, but I also need to hold on to all these things. So I need to cover my weight and the tension. Okay? The tension is going to depend on how much it's supporting, but then there's also going to be a jerk on the cable of another 1400. So we're going to end up adding on those numbers. So we have 1000 plus the acceleration jerk on the tension of the cable of 1400. So the cable is going to feel 2400 newtons. Okay? Now the helicopter has a problem. It has to feel the tension, force of the thrust, which is the helicopter. We're going to need to figure out all the forces. We need the thrust to cover the weight. Okay? Plus, it needs to cover the tension, which is pulling on it, which we found to be 2400. Okay? Plus, we need to make sure that, okay, so we have our this one right here and our tension, and then plus we want an acceleration due to acceleration, which is going to be 1400. Okay? So we need to add all those together. Clear. 6,000 plus 2,400 plus 1,400. So it needs 9,800 newtons to be able to hold these objects and cover itself and fly upward. So that is a very tricky problem. You have to think it through like that, okay? There really won't be much in here to do like these, but I did this one just so you can understand how to find numbers and add them together. But most time we're going to give you things that are not accelerating. They're just going to be at rest. So there's a couple examples and to do some more complex problems, okay? Thanks for listening in. We appreciate it.